For the next graph that we're going to take a look at, we are going to use the graph that looks like this. So go ahead and glue that one in. Now, again, we're using the same directions that we used for part A because this is still the same kind of GP. So we can go ahead and we can follow the same toolbox items that we have there. So the first thing we said was to create a table of values. So my first X value is here at 0. We have 1, 2, 3, 4, all the way up to 8. The coordinates for the point at 0 is 0, 9. We have 1, 2, 2, -3, 3, -6, 4, -7, 5, -6, 6, -3, 7, 2, and 8, 9. So we want to take a look at and check for the common ratio and or common differences. So let's go ahead and check our differences here. The difference between 9 and 2 is 7. Between 2 and -3 is 5. Between -3 and -6 is 3. Between 6 and 7 is 1. From -7 to -6 is 1. From -6 to -3 is 3. -3 to 2 is 5. And 2 to 9 is 7. So clearly we don't have a common first difference. So let's go ahead and check our second difference. The difference between 7 and 5 is 2. Between 5 and 3 is 2. Between 3 and 1 is 2. Now notice that there's no difference between those because they're the same number. Between 1 and 3 is 2. 3 and 5 is 2. And 5 and 7 is 2. Now, the reason that this happened, the reason that we got this 0 is because that point that we got there was the vertex from our graph. So what we're going to do is we're going to leave that off and notice that we have that same second difference, okay? So basically, when we're looking at a function that looks like this, we want to look at that one side. And so if we start at that value, you'll see that from that set of value, the second difference was the same, or if we were even looking at the other side of the graph, which are these values here, that those second differences are the same as well. So we do have common second differences here, which indicates that we have a quadratic function. Because the second differences are the same. Now remember in the directions for these questions, I want you guys giving 2 different reasons as to why you chose the function that you chose. Now I know that quadratic functions are new to us, so I want you to take a look at our graph and notice the shape. It's a U type shape. And this shape right here is called a parabola. And anytime you have a quadratic function, your shape of the graph will be a parabola. So we're going to add that into our toolbox. Shape of quadratic is a parabola. And then I'm just going to write in parentheses, it's a U shape. But I want you guys making sure that you're using this proper term because parabola is a word that we will continue to use over the semester. So again, it's that U shape. And so down here in our description, we're saying quadratic function because the second differences are the same in the data. And the graph is a parabola. So that is our function here. Now we want to write the domain and range for this graph as well. So let me shift to a different piece of paper so that I have room for that. Now we're writing our domain and range in both inequality and interval notation. So starting with the domain, those are all of our x values. So we read our domain from the left side of the graph to the right side of the graph. So the very left side of our graph is here. Get my marker to work. This one doesn't want to work. So that's the very left side of our graph. And here's the very right side of our graph. And so our domain falls between those two lines. So our graph goes from 0 all the way to 8. So our x values are from 0 to 8 and everywhere in between. So 0 is less than or equal to x, which is less than or equal to 8. Now remember, this is inequality notation because we have those inequality symbols. And if we were to write this in interval notation, we use those same values and we put them in brackets. And then for the range, we read that from the very bottom to the very top of the graph. So the range goes from the bottom, which is here, to the very top, which is here. So the range is from -7 to +9. And those are our y values. So y goes from -7 to +9, but it is also everywhere in between. So -7 is less than or equal to y, which is less than or equal to +9. That's our inequality notation. Then in interval notation, it's from -7 to +9 with our bracket.